Hey everybody, it's Mr. Mott. What we're going to do is we're going to go over how to do some of these more complex gram-to-gram calculations using the equation. Okay, so the first problem says if we have 132.8 grams of NaOH that are actually produced, how many moles of H2 must be also produced? So what we want to find out are moles of H2, and what our given is 132.8 grams. And this is for NaOH, to be really explicit about labeling everything and identifying it. So you're going to bring your units across, and you have moles of H2, and we have grams of NaOH. Okay. So now, again, we have two different chemicals being compared. The only place they do that is the equation. So for when I see H2, okay, that's right up here, and the equation says there's 1 mole of H2. It also says there's 2 moles of NaOH. However, we want to have this in grams. So what you would do then is you're going to take 2 times the molar mass of NaOH. Now for NaOH, the molar mass, so you have 1 Na, you have 1 O, and you have 1 H. So the masses are 23 for sodium, oxygen is 16, hydrogen is 1. That's going to add up to 40. Okay. So 2 times 40 grams is going to be 80 grams. So in other words, 2 moles of NaOH has a mass of 80 grams. So I'm going to put 80 on the bottom here, and then for moles of H2, I'm going to put a 1. And it's just that easy. Okay? So I'm going to take 132.8 times 1 divided by 80. Okay, and we get about 1.66 moles of H2. For your units, always kind of go back to what you wanted to find out, and that's it. Easy breezy, right? The second problem, using a different equation, says if we have 0.45 moles of AgNO3 is consumed, how many moles of Al must also react? So how many moles of Al is our problem? And we have 0.45 moles of AgNO3. Okay, so I put moles of Al on top, moles of AgNO3 on the bottom. Okay, bringing our units over. And so then from the equation then, you have 1 mole of Al and you have 3 moles of AgNO3. So 0.45 times 1, so 0.45 divided by 3, should give you about 0.15, and that's moles of Al. Okay, so you didn't have to do any grams calculations in that one. That's not too bad. And so then what do we need to do? So then what's nice is that since it's moles to moles, you're just using the numbers from the equation. Okay. Third one down here, the reaction is run to completion. 88.2 grams of water are produced. How many grams of FeOH3 must react? So we're only dealing with water and FeOH3. I'm sort of ignoring this one right now. The equation says we have 3 moles of water and 2 moles of FeOH3. So let's set up our given and our wants. We want to know how many grams of FeOH3. Okay, and we have 88.2 grams of water. Okay, and so I'm going to put grams H2O on the bottom. I'm going to put grams FeOH3 on top. And we have a little bit of work to do because the units in our equation where these two chemicals are being compared, the units are in moles. So let's take the molar mass. Let's figure out how many grams 3 moles of water is equal to. So H2O has a molar mass of 18 grams per mole. Okay, 2 from the hydrogens, 1, and then 16 from here. So 2 plus 16 is 18. So then you take 3 times 18, and that should equal 54. Okay. All right. So we can take 54 grams of water and put it on the bottom. And for FeOH3, again, we have to do our molar mass. So, so you have in this equation, you have Fe, you have 1 Fe, you have 3 O's, and you have 3 H's. So Fe, or iron, is 55.8. We have 3 times 16 and 3 times 1. So 55.8 plus 48 plus 3 should equal about 106.8. And so that's your molar mass. So we want to take 2 times 106.8, and that's going to equal 213.6 grams. So that's what we put here. All right. So what we really said is that we know from the equation you need 2 moles of FeOH3 and you will make 3 moles of water. If I wanted to measure out all my ingredients and do the recipe exactly as it's written, I would measure out 213.6 grams of FeOH3, and then I would make 54 grams of water. Okay? So that's sort of the relationship there. That's how I can compare these two very simply. Okay? So now I'm going to take 213.6 times 88.2 divided by 54. Okay? And I get about 349 grams of FeOH3. Okay? So those are sort of all the 3 different types of problems you can have. You can have mole-to-mole problems like in our second example. You can have sort of mole-to-gram problems like the first one, and this third one is grams to grams. All right? Hopefully that was helpful. You don't see too many videos using this method, proportions. So hopefully that was helpful, and leave me some messages if you have any questions.